All right, guys, please get your phones out.
Yeah, I will. Phones up, headphones out. Grab your packet and a calculator. This is for my class, so just so you know. What? Not right now. Only my teacher is gonna see it, so I'll mention it. It's funny. Yeah. All right. Actually, there we go. Heidi.
Here for today, I'm going to use yeah, just for notes.
All right, well, welcome. So today I have to record myself teaching. So I have a headphone in to be a microphone. So that's why it's in. I'm not listening to music while I'm teaching you. So yeah, today we're doing 9.4. Let's start working on the bell work. And then we're gonna spin the wheel for who has to start. No, that's fine. What's up? Yes. It's only going to be seen by me and my teacher and Trey Olshan, and that's it. So you don't have to be super careful or anything. It's just it's to watch me, not to watch you. In the fall, if everything goes well. If Mr. Yeldon doesn't fail me. I know. Wherever they hire me. Hopefully this district. On that. 20 seconds, and then we'll spin the wheel. If you're done with, we're going to do question 1 and 2, and then we'll give you some more time to do question 3 and 4, but check over with the people around you. All right. We're spinning the wheel. Geo for the first one. And then question 2. Make sure to check with the people around you, see what they got, see if you got the same answer. So Monty for number 2 and Geo for number 1. Mm-hmm. Wrong thing. There we go. You ready to come up? Write the work and the answer, not just the answer. No? Well, that's not no.
Or B 14 over 5.
Blue or even numbers. So we got to add up all the blue marbles, all the even marbles, and then subtract the blue even ones, right? That's our equation.
It's like that. Like, are you gonna... I try to like.
Yes.
Yeah.
Mhm.
Yes.
Yeah, that's what this part is.
And then you.
This is 4.
What's that?
I don't really know. This is 9.4. I mean 9.3.
Yes.
Did I do it right?
Mhm.
Oh, okay. Cool.
You gotta do this. It says Janelle draws 1 card from a standard deck of 52 cards. It says determine the probability of either a jack or a queen. So the probability of a jack, 4 out of 52, plus the probability of a queen, 4 out of 52, reduces, it's 8 out of 52 or reduces to 2 out of 13. There's nothing to subtract because you cannot have a jack and a queen at the same time. How'd you get there? Yeah, but how'd you get there? Yeah, you gotta write the fractions. Oh my. And then this whole thing, right? So yes, it's even or blue. So we're including all these numbers because they're all blue. And then 2 and 4 are even red marbles. So another way that you can do this is you can take that we have 10 out of 14 is the probability that we get a blue marble plus the probability that we get a even numbered marble, which is 1, 2, 3, 4, 5, 6, 7 out of 14. Wait, 7. Yeah, 7 minus the blue and even numbered marbles. If we use our equation, that should be 5 out of 14, which in the end, 10 plus 7 is 17. 17 minus 5 is 12. 12 over 14 or 6 over 7. Okay, now we're going to spin for questions 3 and 4. Question number 3. Spinning. Jared, your question number 3. Jared, question number 3. And question number 4. Diego's not here. That's true. Another one. And Luis, question number 4. Jared and Luis. All right. Remember our equations? 0.45 and 0.6, but yes.
What do you mean?
0.45, 0.6, 0.3. So you just have to put a decimal point in front of each of these.
I don't, right? All right.
So yeah, it's 0.45.
Yeah.
Yeah, you just gotta do 0.45 plus 0.6 minus 0.3.
Oh.
There you go.
No, you don't.
You don't have to, but
You get 1.35?
it should be 0.75. You gotta subtract the and. The one where they're both in common, you have to subtract
I
it.
literally wrote it down.
So like for this one, we have Jack, yes. Club, okay. But what about the Jack and Club? What do we have to do to get rid of that one?
Would it be 51?
The 52 is still fine for this part, but we have to subtract an extra 1 because it's...
51.
No, 52 is still fine. Dominator's fine. So this is all the Jacks.
Uh-huh.
This is all the clubs.
Yeah.
But what about the Jack that is a club? We have to subtract that extra 1,
So it's just
right? We got to subtract. Yes. Yeah. There's every number in each suit. (16 over 52, which is 4 over 13.
Wait, you said 16?
16 over 52. Oh, it'll give you, it'll reduce it to this. Okay, so Janelle draws 1 card from a standard deck of 52 cards. Determine the probability of drawing either a Jack or a club. So we kind of mixed in 2 steps here, but the probability of a Jack is 4 out of 52. The probability of a club is 13 out of 52, which we talked about. However, we have to subtract our 1 out of 52 chance of getting a Jack that is a club. Okay, we're always subtracting our and statement. In this case, it was a Jack that was a club. So we ended up with 12 out of 52. And that's how we got our answer. Here, for question number 4, it gave us all the numbers. Obviously, it's 0.45. So the probability of A plus the probability of B minus the probability of A and B, which gives us 0.75 as our probability. Okay, what's up? Because it says or, if we said it was 13 over 52 and 4 over 52, we'd be counting the Jack twice, and we don't want to do that. That's why we have to subtract the one that is the and statement. That's why the equation from last time, actually, if I can go back, had that subtracting the and statement so that we can get rid of the double counting. Okay. All right. Looking at example 1 for 9.4 today. So we'll be using tables and tree diagrams to model possible outcomes in counting problems. So suppose at a particular restaurant you have 3 choices for an appetizer: fried pickles, artichoke dip, or cheese curds. Tell your partner what you would pick out of those 3. None is an option too. Okay. And it says that there's 5 choices for main courses. However, there's only 4: bacon cheeseburger, French dip, fettuccine alfredo, or shrimp scampi. Tell your partner which one you'd pick out of those 4. All right. All right. So you can mix and match all these options. If you are allowed to choose exactly 1 item from each category for your meal, how many different meal options do you have? So one of the options that we can do to solve for this is to make a table. There's a table for solution 2. There's a table there for you. It's got 1 extra row that you can cross off on the end. But what we can do is we can start writing down our different values. So to make it easy, I'm going to shorten each of the different options. So fried pickles, artichoke dip. Thank you. I agree. Artichoke dip and cheese curds. Okay, what's up? Solution 2. You don't need to make a whole new table or anything. Okay, so I'm just kind of making my table. Bacon cheeseburger, French dip. Make sure for all the ones that start with an F, you put a second letter because we want to differentiate them. Fettuccine Alfredo, and then shrimp scampi. Okay. And then we can start entering our data into our table. It's a lot easier to just kind of write the first letter. So an example would be fried pickles / bacon cheeseburger. And then we just got to fill out the whole table all the way through. Fried pickles, French dip, fried pickles, fettuccine alfredo, fried pickles, shrimp scampi. We can just keep going to fill it out. As many of you are probably noticing, there's a lot of effort to find how many different options. The question didn't ask us what are all the options. It asked us how many different options are there. So doing this can expend a lot of extra effort that we have other ways of solving. So C, B, E, C, F, A, C. We'll all finish spelling that out. Yeah. So on your homework and the like, you won't be asked to fill out a table. You'll just be asked how many different meal options do you have, and you can pick this option. However, it's a lot of extra expended effort. Another way that you can do this that is also extra expended effort is right below. Solution number 3. You can make a tree diagram. The way that you can kind of read it is, we say we want a hamburger with a salad. We'd have hamburger, salad is an option. Fajita soup is an option. Pizza, bread is an option. So we'd be reading top to bottom, going down the table. Again, a lot of expended effort to write all of that. And we have an easier way. So solution 1, we're going back to that one. The other way that we can solve for the total different options is by taking the amount for the first option times the amount for the second option. So we had 3 choices for appetizers. So appetizers. Is it an E? Yeah, it is. Appetizers times the amount of main course options. Tell your partner what numbers should be going in for appetizers. Hearing mixed answers. Should be 3, since there's 3 different appetizers, times 4 different main courses. I know it says 5. That was from before we rewrote the question. So 3 times 4, it's just 12 different options. So if we go back here, we made a huge table just to see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different options. Here we just took 2 numbers from the question and multiplied them together. It's a lot easier. This is the most basic of ways that you will be working with different combinations. And yeah, so we'll be expanding from here, but this is called the basic counting rule. If we are asked to choose one item from each of 2 separate categories, where there are M items in the first category and N items in the second category, then the total number of available choices is M times N. This is sometimes called the multiplication rule for probabilities. One thing to note is that this expands to how many ever different options you have. Say you have, we'll get to an example later, that's appetizers, main course, and dessert. So there's 3 different options. We just multiply all 3 of them together. That's how it expands. It's just whatever the number of items is times the other number of items. All right. So our first real example, there are 21 novels and 18 volumes of poetry on a reading list for a college English course. How many different ways can a student select 1 novel and 1 volume of poetry to read during the quarter? So our numbers are 21 novels and 18 volumes of poetry. So we need to take our novels and multiply by our poetry. Partner A, tell partner B what number should go for novels. Partner B, tell partner A what number should go for the poetry. 21, and 18. Put those in your calculator. Put them together. It's a lot of just quick calculator work. Seeing 378 for most people. If you did not get that, check with your partner, see if they got it right. Ask them how they did it. All right. 378 different options. Okay. Suppose at a particular restaurant, you have 3 choices for an appetizer: soup, salad, or breadsticks. 5 choices for a main course: hamburger, sandwich, quesadilla, fajita, or pasta. And 2 choices for dessert: pie or ice cream. If you're allowed to choose exactly one item from each category for your meal, how many different meal options do you have? All right. So tell your partner which or what our 3 different our 3 different items are. Our appetizers, so if I remember that, our main course, 5 main course, this thing likes to slide, and our dessert. And there's 2 options for dessert. So we can plug in our numbers. We have 3 choices for appetizers. We have 5 choices for the main course. And we have 2 choices for dessert, which gives us a total of 30. 30 possible combinations of the 3. Okay. For example 4, you are making your schedule for next semester. Most of you, not most of you, unless you are going on to college, you won't have a next semester. But if you are, you're making your schedule for next semester. You have 5 choices for your math class, 8 choices for your English class, 3 choices for your communications class, and 4 choices for your elective. How many different schedules are possible? So again, we're gonna go through each one. Our first option is our math class. Our second choice is our English class. Our third option is our communications. Sorry, not the whole word. And our fourth choice is electives. So kind of ran out of room. Okay, so check with your partner, see if you got the same answers, plug in the numbers. Should be good. Yep. Cool. All right. So again, this stuff's kind of quick once you get it set up. We've got 5 choices for math. 8 choices for English. And then 3 choices for communications. and then 4 choices for electives, which gives you a total of 480. So I saw for most answers. Great. Okay. Example number 5. Partner A, read the next one to partner B. All right. So my first thought when I see this question is that I should be multiplying the 3 questions times the 2 possible options, true and false. However, that's not the case. That's not what we're going to be doing, because each separate question, so question 1, question 2, and question 3, each have 2 different possible answers, true or false. So we have 2, a 2, and a 2. However, just like what we've been doing in our previous questions, we have to multiply them together. We shouldn't be adding. So we end up with 8 possible quiz questions answered. So may not be exactly what it seems at first, but there are 8 different possible options. Okay. And now we're going to do one more example. It's not on your paper. So you're going to go underneath the basic counting rule section, and we're going to write out this example. It's important because you'll see it multiple times in the future. Just write it out. You don't have to write out the whole thing. You can shorten it however you like. Just make sure that you put, probably should put license plate and then the 2 numbers, 4 capital letters. Okay. All right, starting with repetition allowed. So repetition is similar to our replacement that we were doing from the last couple of lessons, where when repetition is allowed, it's like you are able to replace the card. Or in this case, you're allowed to repeat the same number over and over again. So if I had 2 possible numbers that I would want, I could have a 2 and then another 2. When repetition is not allowed, I can't have that. So it's just like not replacing, where you take out a jack, you no longer have an extra jack there, you've lost a card. So when repetition is allowed, we have 1, oh, yeah, that's fine, 2, 3, 4, 5, 6. We have 2 numbers and 4 letters. Okay. Tell your partner how many possible numbers you can have. Hearing 9 and 10. The answer is 10 because there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 possible options for number. And then again, because repetition is allowed, we can have 10 possible options for the second number. And then again, tell your partner how many letters are on the alphabet. 32. There should be 26. There should be 26. So there's 26 possible options for the first letter, 26 possible options for the second letter, 26 possible options for the third letter, and 26 possible options for the fourth letter. And now, what have we been doing to all these numbers this whole lesson? Multiplying them. So it's this really, really big number. Plug in your calculator. The answer we should be getting when you plug this in is 45,697,600. Anybody else get a different answer? Okay. Now, we're looking at when repetition is not allowed. We're still looking at our 6 values, so our 2 numbers and our 4 letters. But this time, repetition is not allowed. We can't repeat a number or a letter. So for our first number, we still have 10 possible options. But how many numbers do we have left after we pick one? 9. Same with the letters. We started with 26. We took one out. Now we have 25. And then 24. And then 23. So the statement of repetition being allowed or not is incredibly important to solving the equation. So when we plug that in, 492,000, 32 million, 290. Yeah, 290. All right, you should be getting 32,292,000. That is relatively a very large difference. That's almost a third of the possible options being taken away. The reason that these numbers are so large, though, is because there's so many different people that are driving and they all need unique license plates. So that's why the numbers are so large, so that they can keep all of their data in place and you don't get pulled over even though you just have the same license plate as somebody who should be. All right. So that's it for notes. We're working on in your packet, 9.4b. So there's a part that just says 9.4. You're going to skip that and cross it out. And then once you finish 9.4b, you can come to my desk to check your answers. And that is all the homework. Here we go. What was that? Oh, yes. If you were absent yesterday, come see Miss D'Alton. You're going to take your quiz from yesterday. This quiz is just on 9.1 and 9.2. So it doesn't have any of the plus, plus, minus stuff, or this stuff that we learned today? Yeah. On the quiz itself, or? Oh yes, this one is wrong. Yeah. That one is still 1/6. Yeah. Mm. I didn't want to say thank you guys for being cooperative for me recording my video. Again, only me and my 2 teachers are going to see it. So yeah, I have to watch I have to go home and watch myself later. Not a fan. Yeah. What's up?
Just the 0, or can I put 0 over 36?
Well, if it is 0 or anything, it's just 0, right? So you can just leave it at that. What's up, Jerry?
For this one,
Yeah.
would it be, is it times or is it
Female and earned an A.
so would it be like this or not?
No, because we're just looking at when a female earned an A, which is 10
Oh, so
out of our total.
But if it was or it'd be like this?
It should be or it'd be plus. And then you'd have to, when we have or, we have to add those two together and then subtract the both, right? That and portion that we had from the notes from last time, the 9.4 or 9.3. I mean, what is it? That part. The and.
Yeah.
We have to subtract that part if we did an or statement. But yeah, so the only one that is female and earning an A is this 10.
Oh, gotcha.
And we're 7 total. Unless it says given, you are always using the total. Just the hint. Yes. For this one? Or for that one?
Yeah.
5's on both rolls. So there's only 2 rolls, right? So you only have to multiply it twice. Since it says both, that means only 2. Yeah. So we only have to do it that. Yes. What's up?
Maybe this one, right? Because it says it's allowed, so 10, 26. Okay.
That should be good. All right. One more thing. If your calculator gives you an answer on this homework that has something like, didn't mean to do that. All right. Like a 3.7, blah, 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 times 10, or E, actually. E to the 3rd or something. Not 3rd. It'll say something like this. So that 11 means you have to take the decimal and you have to move it over to the right 11 times, and you just keep going. Okay? That's how you change from, oh God, what's the word? Scientific notation to regular notation. So all this means is you're multiplying by 10 to the 11th power. Oh yeah, you had to move that one.
Huh?
That's what I was talking about. Yep.
What's the EG?
Example.
Oh, so like it's just these are 6 choices then.
Yeah.
Okay.
Well, if it's a number, how many choices are there for each number?
Oh, so I have to do 3, 2, 3.
This is just an example of what it could be. So you can still use any number. So how many numbers options are there? Just like up here.
10.
So it'd be 10, 10, and 10 again.
Okay.
Is it like from cards, from the deck
Yeah.
of cards? Okay.
So it's still using that same without replacing part. So you're saying
Okay, it's for this one that we only do 3 or all 26?
all 26.
Oh.
It's just showing you an example. What's that?
So if I put 10, 10, 10, do I have to put 26, 26 because it's also letters?
You already have them here.
Was
So it's 3 letters followed by 3 digits. So just ignore that. If you know what that means,
okay.
you can just ignore the ABC part.
Okay.
All it was doing was giving you an example of what your license plate could be. What's up? Oh, you're doing that one, so you got a weird number, right?
No, not
Can't round it. You gotta move the decimal over every time. Yep. You gotta keep going. So let me write that on the board. I'll take your number. Yes. Yeah, great. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11. Looks good.
Hey. Oh, when is it? Is this the total? Will it be this one, or will it be in total of all?
It says given the child is a girl,
Yeah,
right?
so it's 95. Will it be 95 or 68 to 15 or 50?
Well, whatever our given is the total that we're looking at. So what does it say our given is?
60?
Yes. But I meant what does it say given? It says it's a girl, right?
Yeah.
So then our given is our total. So you were right.
And then
I was just trying to get you to verbally say it, but that works. God. Yeah, I know. Like I wake up, I feel great, and then I start coughing, and it doesn't stop. My dad's in the worst of it right now. And he's just like, he had the same, like, you feel like there's glass in your throat. Yeah. You want to come check your answers? No, they left it in standard.
I'm just gonna
Yeah.
hope that I got it right.
Well, you can kind of tell. You should be able to tell. Did you finish? Thank you. If you don't finish your quiz, come talk to us and hopefully come in tomorrow morning or stay after school.
Wait, I forgot what we did when there's a plus.
So I wrote out the decimal, right? Okay. And it says e to the 11th. So we need to take this decimal and we need to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. And then we have to add zeros to fill in the gaps. All right? Yes.
For this part, we're not replacing the part that you had taken out, right? It just goes down to 51.
But it says a 9, right?
Oh, yeah.
Ignore the diamond part. It says 9. How many 9s are there in the deck?
Oh, wait, 4.
Mm-hmm. Okay.
Should be the same, right?
Yeah, because there's no 9s that are also queens, right?
So it said this one is wrong, but I don't know how that's wrong.
Let me grab that. Number 6?
Number 7.
Number 7. That's weird.
Did I do it wrong, or is that?
6, 10 times 10. Why is that so different?
I don't know what happened. Got everything else, right?
Well, maybe that is right.
What does it bring 9 or 10?
0 through 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
How many three-letter words?
Oh, so if it's all the same number, another thing that we can do really quick is we can take that first number, so it's the same amount of options every time. Rather than multiplying 2 times 2 times 2, we have 3 questions, so we can put 2 to the power of 3. If it was 100 questions, it'd be 2 to the power of 100.
Because 2 times 3 is 6, so we can't do 2 times 3, but 2 to the power.
Yes. Thank you.